MakerEd, Makerspaces and Coding by me, James Sigler. MakerEd is hands-on, generally a wide variety of hands-on activities such as building, computer programming, and sewing to support learning, a playfulness and experimentation mindset, growth and iteration, and collaboration and community. Does it improve learning? Researchers are studying whether making improves learning, especially test scores. The maker movement is about people who like to figure out and fix things with their hands. The makerspace concept has emerged from the maker culture as associated with the Make magazine and blog, as well as maker fairs, hackerspaces, and DIY websites. Makerspaces are also related to the hacker culture that is based around technological experimentation, development of computer hardware, and exemplar idea making. The do-it-yourself, or even better, do it with others mindset is the telltale sign of the maker movement. The benefits of MakerEd are a sharper focus on equity and diversity since the movement trended towards middle class and white boys' interests and experiences. It includes inspiration, inviting students to participate in the creative economy and direct their own futures. Students are working together to use their creativity to make something new. Makerspaces bring people together who share a wide variety of interests, including textile craft, robotics, woodcraft, electronics, digital fabrication, mechanical repair, writing, gaming, or any sort of creation. It's a diversified culture of making, but it is unified by a sharing engagement to collaborate for open exploration, curiosity, and creative ideas. Students talk and learn from each other as they think about how to make something. It benefits in innovation, serving as a catalyst for grassroots invention. There's a spirit in makerspaces to transform the patron to a producer rather than a consumer. The maker or makerspace users include inventors, artists, innovators, crafters, designers, and youth or school groups. When they encounter a problem, they have to examine their project carefully, think through how it is made in order to solve it. The knowledge that is made of complex networks that are developed through makerspaces are because of the diversity of people that identify as makers. Many makers begin by taking something apart to see how it works, like this Elmo. However, some of the cautions are that school is rigid and sometimes that unstructured activity that's needed for makerspaces might be corrupted. Some also fear that corporations may take over maker education, especially as they focus on STEM. Many makers begin by taking apart things to see how it works. However, to give students the free time they need to explore is hard. It's not easy to give kids freedom to produce creative solutions to complex problems in just 40 minutes, but teachers who believe in it have to start somewhere if they want to make change. In Bloom's taxonomy, creation is the highest level of learning. This creative thinking and knowledge making take place in a collaborative environment that often exists in a physical and digital environment at the same time. This is Mythbuster Adam Savage. He started out as a prop designer, making props for the original Star Wars and Indiana Jones movies. As he's also done props for many other movies as well. He has an incredible shop for making things, especially authentic replicas of props from movies and TV shows. He often makes elaborate costumes for cosplays, like this one, during conventions like Comic-Con. He's become a huge advocate for making and the maker movement. This makerspace was made by my friend Dr. Eric Langhorst, a middle school history teacher in Liberty, Missouri. Before, you can see that he started out with a corner in his garage that he cleaned out, and he turned it into an area where he could make stuff in a makerspace. Failing better is one thing that makerspaces can do in schools. Failure is necessary in learning. For all the talk of how this sometimes painful process is vital to growth, people rarely share examples of how to facilitate room for healthy failure in classroom. The first ideation of their project isn't going to work the way they want it. If it does, they're doing it wrong, and it isn't rigorous enough. With this in mind, makerspaces allow educators to embed many lessons in these tasks that will help students begin developing the grit and metacognitive skills needed to analyze and move beyond their temporary failures. You have to bridge the gap with administration for makerspaces in schools. While tinkering alone is a valuable learning experience, most educators currently work in a system that doesn't assess students on their ability to tinker. Educators must prepare curricula so that the projects are standards aligned and link directly to the work that students are doing in their classrooms. By creating curriculum-wide, project-based lessons and units that offer evidence of student literacy and growth in critical thinking, as a result of makerspace learning experiences, you will find that your idea is more easily accepted. Making motivation in makerspaces in schools means, as a rule of thumb, project-based learning and school makerspaces work much better as tools to motivate students than any marble jar, point system, or promise of pizza ever could. One of the first comments from any teacher or guidance counselor who spends time inside a makerspace is how well a certain student is understanding, focusing, and behaving on the project in front of him or her. By developing recurring lessons around project-based themes, with the reward of students visiting the makerspace, teachers and counselors get a golden chance to reach the students with whom we might often struggle to connect. In return, we can use this motivating factor to help these students begin budding in the areas in which we want them to grow. Makerspace projects have the ability to help struggling students see the value of their classroom work, why it's relevant, and how it shakes out in real, tangible ways. In evidence-based success, students who complete maker-based projects create real-world things. In order to see a project to its completion, they often need to overcome several rigorous intellectual challenges in the process. It's a valuable tool when a teacher can point to a real-world student-made artifact as evidence that all students, particularly struggling ones, can thrive when we instill the necessary confidence in them. It goes a long way in a student's mind when he or she hears you say, "You just built a wind turbine that actually charges a cell phone. That is way harder than this equation." It is something that they can hold on to, use for reminding themselves that they are capable, and feel proud about it. When we continuously build evidence of a person's success, that person becomes successful. Coding is a virtual form of making. It refers to writing computer code that makes computers run. Again, this is the origin of the hacker culture. What's an hour of code? It's a 1-hour activity. Students of all ages can choose from a variety of self-guided tutorials from kindergarten up. A spark to keep learning computer science. Once students see they can create right before their eyes, they're empowered to keep going. Women who try AP science courses in high school are 10 times more likely to major in it in college. And Black and Hispanic students are 7 times more likely. With Hour of Code, students snap together code blocks to write sample programs. Every 21st century child should have a chance to learn about algorithms, how to make an app, how the internet works, just like they learn about photosynthesis, the digestive system, or electricity. I'm sponsoring an Hour Code Club at my school. Fourth graders are spending 3 hours coding using the Star Wars, Minecraft, and Frozen modules on Hour of Code. I'm also using the code.org resources to show them how the coding blocks relate to the JavaScript code underneath. I just click a button and it shows us the code. They already are excited about coding. Now I hope to inspire them to continue learning how to code after school is out. Minecraft. What kid hasn't heard of Minecraft? They consider it a game, even though it doesn't keep score or have a winner. Even kindergartners can create in Minecraft. It's a complex environment with recipes to mine and build things. Even though they're not actually learning a coding language, they are learning creative and problem-solving skills and that are used in coding, while also creating. Once they love Minecraft, they can start modding Minecraft by changing the code that runs it. Learn to Mod is one tool to use to create those mods. This is where they actually start learning how to code. Tinker is a code.org partner and another place to learn how to code, including modding Minecraft. Lightbot is also a code.org partner where they click code blocks together to solve a puzzle, including lighting up blocks. They also learn to program several processes, like smaller blocks of code, and then run these processes from the main program. Scratch is really the creator of programming blocks. Developed at MIT's Lifelong Kindergarten program, they wanted to give kids an easy way to learn how to code. As virtual making, coding has many of the same benefits as a makerspace. Creativity, problem solving, critical thinking, logic, and they get to create a video game instead of just playing them. Raspberry Pi and the Arduino circuit boards are small, cheap computers that can be easily modified and used in many different projects. It's a $35 Pi really grew out of the maker movement. And robotics. Robotics is really where the virtual coding space meets the physical makerspace. A maker has to build the robot, then write the code to run it. Robots are an excellent replacement for repetitive tasks, which means those low-skilled jobs will be replaced by robots and computers, even autonomous vehicles. High school graduates may soon be replaced by a robot, as well as many other manual labor jobs. Someone will need to design, build, and program all those robots. Currently, there are more than 500,000 open computing jobs in the United States. These jobs are in every industry and every state, and they're projected to grow at twice the rate of all other jobs. 71% of all new jobs in STEM are in computing. 8% of STEM graduates are in computer science. So that means that Careers of the future are going to require at least some post-high school education. By helping bring together the maker movement into their school, educators can help usher in the future of education. Through planning curricula-aligned projects, school and community makerspaces can help once again to democratize education and build early communities, learning communities, where all students have a chance to grow into thoughtful and confident leaders of tomorrow. I didn't get the last